welcome to the second half of the Commercial Vehicles Conference. Some people call the after lunch slot the nightmare slot. If you're all feeling pretty good after your lunch, and someone suggested that maybe we should do some press-ups on the spot, a bit of running. What do you think? No? Okay, maybe not. But certainly you'll be very interested to hear the second part of our conference, which moves to some very product-specific opportunities in the area. We heard this morning about the big business environment in terms of regulation, in terms of opportunities, in terms of market size. We're going to learn this afternoon from a number of experienced speakers about new product opportunities and considerations, lubricants, tyres, and, for example, also fleet and leasing. So I'd like to ask Ranjan to take the stand. Ranjan is the Regional Sales and Business Development Manager for ENOC Lubricants. Please come in. Thank you very much.
Good afternoon. How many of you are from the lubricants field over here? One, two. All of my colleagues, by the way.
You're friends again.
So nobody knows better than me. It needs to speak. I'll introduce myself. My name is Ranjan. I work for ENOC Lubricants. A couple of words about ENOC. ENOC is a government of Dubai organization, and it's upstream, midstream, and downstream company. And I work for the lubricants stream only. 16 years we are working, and the company is 22 years old. In 16 years, we have done quite a bit in terms of marking our footprints across the globe. We're in over 60 countries now. And it's considered as the fastest growing lubricants company from the Middle East. So here I stand to present a couple of products that we are introducing and what brings around this change, why we need to introduce these products. Before that, let me try to thank my colleagues who helped me in putting up this presentation together. The number of slides are quite huge, but I put in a lot of pictures. Remembering your words, you said nightmare session, it's actually a graveyard session. So for me, I didn't take my lunch, I'll have it after my presentation. And the other thing I would like to mention over here is that ENOC Lubricants, being a fairly new player in the global market dominated by the multinationals, is trying to create a niche by offering products which others have, other multinationals have, but they don't introduce in most part of the world where the country's regulations are not very high. So you will find the global majors introducing in the northern part of America or the western part of Europe or even to the Australasia region, but not introducing over here. We have just taken that to our advantage. Introduce the latest product and create a difference. So here I go. Okay, the main engine is not coming somehow from the projector, but where it is written energy from combustion, it's actually an engine over there, and we know that when the engine works, it produces mechanical work, it produces noise, it produces friction, it produces heat. So out of the total combustion energy of the fuel, you will find that we are using only 30% of the energy, and the rest 70% is actually going down the waste. I'm trying to explain why are coolants required. So the coolants are required to cool down the engine. If I go a bit more on the process chart, you will find that the fuel combustion inside the engine, then releasing a huge amount of temperature and pressure. The hot gases make the engine work. So we need that hot gases, the expansion of the hot gases to make the engine work. But it also heats up the metals because it's hot. And the job of a coolant is to cool down the metals and prevent it from distortion and seizing. So if you look at the perception of the coolant, which we normally use, I came up with this three. Water is good enough, most people would think, depending on the country. In some parts of the third world, we will feel water is good enough. It's very difficult even to convince a driver to put on the radiator cap. So that's a perception running from the early 1900s. The second is, its job is to cool the engine. And third is, any green color coolant will do. So this is the perception. Why green color? Because most of the German manufacturers, when they have their own coolants, they have it in green color. So that's the general perception of a coolant, what a coolant does. Some of the results of this perception are these. So you see dirt everywhere. It's the deposits. It's the deposits everywhere. You see the second photograph from the left in the middle row. That shows that the hoses have given away. So this happens when your perception is that all green colors are coolant and water is good enough, or that cooling is the only job. So let us see what are the coolant's job actually. Cool down the metals, to protect the metals, raise the boiling point, lower the freezing point. Now that's magic, isn't it? Raise the boiling point of the liquid and lower the freezing point. And of course, the sealant, the hoses, whatever comes in contact with the coolant should be compatible to it. So, what a coolant should have is high specific heat, good thermal conductivity. Conductivity means just taking away the heat, and low flammability because it's working in heated conditions, so it should not be inflammable. It should also have the non-corrosive property. It should have a high boiling point, low freezing point, compatible with all metals and non-metals it comes across, because inside the engine it's not only metals, it's metals and non-metals. And should be non-foaming. Should be non-foaming because foam is air and air does not lubricate. What lubricates is oil or liquid. Air is actually an anti-lubricant. So the foam means there is air bubble over there and it should not be there. Apart from there are these four other properties any coolant should have. People who don't belong to the lubricants industry also can use these fundamentals for their own vehicles they use, or their friends' vehicles with their friends use. Now, the coolant over here, why we are coming specifically to the coolant? Because engine oils, gear oils, turbine oils, everybody has the latest technology available in most parts of the world. Coolant is somewhere taken a back seat and it was not upgraded. So this fundamentals is not from ENOC alone. We are taking the fundamentals from the global developments and trying to merge it with the ENOC vision. So it has to be fluid, solids or gas don't work. It has to be chemically stable, environmental friendly, and ways to avoid human use. Means because it's toxic, it should not be swallowed. So there has to be ways. So these are actually the coolant's job. So instead of just thinking that it's just a cool. In the early 1900s, they used water only. So in water, when it boils, they refill. And when in the winter, it will freeze if you keep it overnight. So drain it in the night. So there is no liquid inside, nothing to freeze. So that was the fundamental principle in the early 1900s when the automobile was invented. If you look at by 1994, the magic of ethylene glycol, or what we call MEG, monoethylene glycol, came up. It still remains the base of every coolant. So monoethylene glycol, if you, I won't go into the details, but just to show the point, if you look at 70% on the 70% concentration, you will see that the boiling point has been increased, and again at 70% you will see the freezing point has been reduced. So 70%, 60%, 50 to 70 is taken to be the ideal concentration of an antifreeze, where the boiling point is raised and the freezing point is reduced. So this property was gained from monoethylene glycol, or from the glycol, but it had its own issues of being very corrosive in nature and colorless and poisonous if swallowed. What has colorless got to do with it? people used to often, because both used to come in bottles, people used to make a mistake of swallowing it as water. So these were the three issues which came up with monoethylene glycol or glycol-based coolant. As I said, it still remains the basic of all the coolants used across the world. So from 1930 to 1990, all sorts of additives were used to take out the three disadvantages we saw, mainly the corrosive nature. So these additives were used along with the ethylene glycol to take away the disadvantages. So they were mainly the corrosion inhibitors and dyes. Dyes to color the liquid so that you don't think it's water and swallow. And corrosion inhibitors is to take away the monoethylene glycol's corrosiveness. So all this kind of corrosion inhibitors had cropped up. And if you see the span, we have mentioned 1930 to 1990. So in the span of 60 years, some of these corrosion inhibitors came up, each claiming its own kind of advantage over the other, but everybody had some issues with something. So we'll see what those some things are. Some were attacking the metallic parts of the engine, some were attacking the non-metallic parts, and some were attacking the alloys. They were not thermally stable, and they itself being additives, and some of the additives being metals, they were themselves getting deposited on the engine parts, giving the same problems what we had, but at a later stage. So the boiling point was raised, the freezing point was lowered, but the deposition kept on continuing. So all the additives which came up to be mixed with monoethylene glycol, this was their rates. Means if you, I won't try to complicate it for the non-lubricants people, but this is how the concentration fell. Means you start at 100% concentration, and within 50,000 miles, the concentration came down to almost zero. So though you thought that the coolant you are using is 100%, 100% was not being used anyhow, 50%, but after 50,000 miles, it came down to almost zero. The driver is unaware because there is no sensor for the coolant to display in the dashboard that the coolant percentage has come down and you should top it up with the coolant. So then came the new advanced technology of additives, and that's the organic acid technology. This is the carboxylic acid technology, and this has caught up across the world. Today, all the new cars, whether it's European, German, Japanese or American, they are all having their own coolants, and own coolants also have levels. So they have the premium one, they have the medium one, and they have the basic one. All of them, whenever it's a premium, go with this technology. And why is that? Because of the four things which were having an issue with only the glycol or the nitrates or the molybdates alone. So this became compatible with metallic engine components, the non-metallic engine components became thermally stable, and the pumps, thermostats, radiators, there were no deposits, compatible with the sealant materials, compatible with the seals, and most importantly, longer service life. We tend to follow a pattern for fuel. We look at mileage, means kilometers or miles per liter. We try to follow a trend of coolants for say 100,000 kilometers. We try to follow brake oil, never fill it up. So it's an automobile trend, and keeping it to that trend, the coolant life has to be extended as much as possible. And when you compare both the earlier one and this one, so you will find that from the 50,000 miles, it went up straight to that 500,000 miles. So that's the level of output current automobile owner expects. So if you take a Mercedes-Benz cooler or a Volkswagen cooler or a BMW coolant or a General Motors coolant, you expect, because that's the trend now, that's the benchmark. So anybody going below is not well accepted. That's only in the service life part. This is what the consumer sees. But what the consumer doesn't see is what we said about attacking the metallic components, attacking the non-metallic components, attacking the seals that we cannot see by naked eye or till the engines are split open. But this is what you can see, you can feel. So the trend has been set now at this level. Now I come to product specific, because I'm from ENOC and I have to talk about ENOC. We completely revamped the coolants, and effective year 2015. All our coolants were monoethylene glycol, some were nitrates free, for some were with nitrites. We replaced it because we found, after testing all the giants, automobile companies, their own coolants, that everybody is following the OAT technology, organic acid technology. So all our coolants now follow the organic acid technology. And I'll just go quickly one by one. This is our top tier product, extra long life. And the point to highlight over here is that up to 650,000 kilometers in trucks and buses, passenger cars 250,000, and 5 years in stationary engines. Now, this, whenever I make a public portrait of a product, it has to take all kinds of factor of safety, it has to take all kinds of working environments. So the figures over here are the minimum possible benchmark that we are talking about. So this has these features of longer service life. Again, this is something which the consumer will see. But if you look at the specifications it's meeting, and as I said that this we have revamped this year, 2015, so we are in the process of getting formal approval from many of them. Why I said many of them and not all of them? Because there are certain automobile companies, especially from the Japanese origin, who do not approve third-party products because they have their own products. Like if you look at Toyota or you have Nissan, Honda, they don't approve a third-party product, neither Shell, nor Mobil, nor anyone. They might have a tie-up, commercial tie-up, but approval, formal approval, they don't give. But they do give the approval that this is meeting the spec. So if you don't find our genuine product, you can use this. But the German automobile industry, which are much more open to the world, they do give approvals, and we are in the process of obtaining approvals from most of them. The product is technically the same product they are using, because the supplier probably is the same organic acid neither me nor Mercedes-Benz prepares or manufactures. It has to be sourced, and the source probably is the same. So we will get the approval from wherever it is possible. For the rest, we give an undertaking that we are meeting the specs. So this also shows that this is covering more or less all the premium cars of the 4 major origins, which is the Japanese, the Koreans, the Europeans, and the Americans. The second one we have introduced is only for the heavy duties. Heavy duties means Caterpillar and Cummins, because most of them have come up with a wet liner system. The wet liner system is where the outside of the liners get in direct contact with the fluid, with the coolant. So they have a particular problem of cavitation and corrosion. So to avoid that, along with the organic acid technology or organic carboxylic acid, we have added the 2 main things, which is nitrite molybdate. So this NN technology is to take care of wet liners corrosion. So the first one is a top tier for all passenger cars. This is predominantly for all the heavy duty equipments where the wet liners are there. I just forgot to mention over here what we have also done for the ease of identification. The label color and the product color inside is kept as the same. So whoever is using it helps us in educating the oil man, the oil operators, so that they don't make a confusion which one to give. So this one has red label, means it has red color product inside. To try and become as foolproof as possible. So if you look at it, has the CAT, Detroit diesel, and ASTM specifications all followed over there. And what we were mentioning about the wet liners cavitation, this is a particular problem found in the wet liner system, will be avoided with the nitrate molybdate technology. The third one is the general one. General one means where we are not talking of premium cars, we are not talking of new cars, when we are talking of general cars. So this can be used everywhere. We are bringing it in 33% just to keep with the market. But the recommended coolant for all your cars, whichever coolant you buy, ENOC or non-ENOC, go for at least 50% if your car is within that 5 years range. because that your operating temperatures are much more, your combustion chamber heat up is much more, so go for 50%. Price doesn't matter because anyway it's going to last over 100,000 kilometers. You forget when was the last time you actually replaced the coolant. So this is the basic, and what we did was we converted the basic, which was a normal monoethylene glycol one, to a OAT technology as well. And guess what? The price actually came down. It didn't go up. So the latest technology and the lower price, it supports us both ways. And ENOC solution, just to summarize, is the overall lower cost of operation and extended wet liner life when it comes to the heavy duty. So just for the sake of the human part, the swallowing part, it's very toxic. It still remains a monoethylene glycol base. So just take care of the medication part, mainly if it is swallowed by mistake. So that completes my first part of the presentation. No need to feel happy, I still have 10 minutes to go. I have a second part as well. I took 30 minutes to introduce everything ENOC has, almost. Okay, the next is the new performance additives from ENOC. I belong to the lubricants industry for the last 25 years. I've been working in this industry. And we always say don't add additives to lubricants. The reason is, what additive we don't know. We are not chemical analysts, we are not sitting in a lab. So the people in the lab know exactly what they are doing. So if you are using a lubricant, don't add an additive to a lubricant. Additive is nothing but a chemical. So if you are adding, you don't know whether you are adding in the right proportion or not. So refrain from adding additives even if you have the best marketing pitch. So here we are talking of performance additive, but to the places where the lubricants is not serving. So we are talking of the fuel additives. This was also one of the very debatable things that being from the non-additive school of thoughts, should we use additives? If you run through this presentation, which I'm going to run very quickly, you will find that it is required. We call it Inaya. Inaya in Arabic means care. So that's our product name. Like for petrol engine oil, we call it Protect. Shell calls it Helix. Shell calls Remula as this diesel engine oil. So for this line, we are calling it Inaya. Again, it's a 2015 addition. So if you look at it, the engines are designed to run clean. When an engine manufacturer, a car manufacturer manufactures an engine, he has designed it for an output where the engine should be clean. He has not designed it that the engine will be dirty, yet it will work to the best operatory measures. Now, who are the people who decide how much cleanliness should be there? Are the OEMs themselves, the manufacturers themselves? It's like the European Union areas, it might be by the countries, and it is also by the brand management by every company. If you look at an additive development, and again I'm talking of this additive is actually about a fuel additives, we're not talking of lubricants additives. So the four people mainly involved is the laboratory, the chemical and research facilities, the engine research facilities, and finally, of course, it has to perform tests. We'll first talk about the diesel additive, and the challenge is only one, that's the injector. What are the challenges? It becomes dirty. If it becomes dirty, you have the drivability issues, you have the fuel consumption issues, because the fuel is supposed to be sprayed in a uniform way, like it is shown over here, if it's a clean injector. If it's a dirty injector, it doesn't spray in the most atomized way. So everything becomes a casualty. The drivability is what you feel, but inside the fuel consumption goes up. The carbon emissions, which is now catching up across the world, that goes up because of incomplete combustion, and your detergent, use of detergent additives will allow the vehicles to, as I said, when the vehicle is manufactured, it is manufactured to a specification for the clean engine. So once this is clean, it will start operating in the design specifications. To the design specifications to which the manufacturer made it. So if you look at it, how the detergents work, it is a very simple way. It gives a protective film, it removes whatever is the dirt, and it replaces it with another protective film. So that's how it basically works. And where is this protected film? It is on the injectors only, both inside and outside. So the solution to deposit control, and if you look at it, this is the dirty one, and then you have the clean one. You have to have the spray in a very uniform way in the right radius. To bring this, the main way to follow is to go for the injector cleaning through injectors, through ENOCs. Now, this was my challenge to my technology, that everybody, there are many products available in the market, and everybody claims that theirs is the best injector cleaner or gives the best pressures. But I need figures. So that's why we are showing this, because we generated first figures and then introduced the products. So we did it with the vehicle test protocol was well defined. So there were two. One is cleanup only, and the other one was to take a clean one, make it dirty, and then again see how ENOC would help it. And if you look at the measurements, it was power restoration, how much of smoke, how much of emission, and how much of fuel economy. All these improvements were there. So we just wanted to measure before we go for a marketing tactic. And if you see, any marketing is always successful if it has figures attached to it. So this is first we did on the on-road mileage accumulation. So the horsepower came down by we used a normal car, used the B5 fuel, which means 5% biofuel added to diesel. And biofuel, when added to diesel, produces more deposits on the injector. So this is forceful usage of biofuel to make the injectors dirty first, and then use ENOC to see where we go. So the recovery was almost 87% of the original power. So if you look at today a Nissan Petrol, which has 320 horsepower, and there is a 10% power loss, we are talking of below 300 horsepower. So you are thinking you are driving a 320 horsepower, but actually what you end up driving after 5,700 miles, which is 10,000 kilometers, is actually a below 300 horsepower engine. So that's where these kind of products come into play. Anybody who has figures, including ENOC or non-ENOC, those can be trusted. So we are talking over here specific 87% recovery of power by using ENOC. This is done after national test facilities. So of course we are taking help of the reliable test facilities to come out with the figures. And if you look at over here, this is SOT baseline, means start of test baseline. And the fuel economy improvement by using ENOC is 4.9%. I'm showing this as a public portrait. So we have the figures and we have the data and everything with us. So if challenged, we have the data to back it up. 4.9% fuel economy improvement is nothing in Dubai. Nobody would even think about it. Nothing in the Middle East or Iran or Turkmenistan, where oil costs or fuel costs much lower than a gallon of water. But in the rest of the world, everybody jumps at fuel economy. So that's what we are trying to harp on. Petrol additive, we had the earlier carburetor deposits. And this is a photograph from, not tested by us, but by Afron, where they say that if it is untreated, what happens? And if it is treated, what happens? These are for the old cars. If you look at the new cars, and everything is about the injectors again. And you can find over here where the deposits come in. And when the deposits come, the spray is not uniform. The spray is not fully atomized. And incomplete combustion happens. This is what the performance should be. If it is only 25% plug, this is how the spray will be. Whereas this is what the actual spray is desirable. So if it is non-treated, this is it. And again, I'm telling you that this was tested at Afron's Ashland facility. So this is what happens if you're using a normal fuel without treatment. And when we treated with ENOC, this is the result which came out. After 1500 kilometers, the intake valve deposit test of a BMW, this was the result we found. And that's why a person who was from the school of thought that no additives required anywhere, we found that yes, we have to provide this for the sake of the countries which are especially receiving dirty fuel. A case in hand is Sudan. If anybody is here from Sudan, they will know that when the 2 months the refinery closes down, the dirtiest of the fuels across the world come and land in Port Sudan. And those 2 months, the sale of all injector cleaners, all diesel injector and petrol injector cleaners, they shoot up by not less than 200%. We're not talking once or twice. So that's how it helps. We tried it in our own cars over here, and for the older cars, greater than 5 years, it made a remarkable difference. For the newer cars, like mine is less than 1 year, I could not feel that much of a difference. But the moment, because here we already have very clean fuels, but even then the 5 years and 7 years did show a marked difference. The acceleration over here, the graph, for the sake of time, let me just tell you that when it was taking somewhere around 19 seconds for the acceleration after 200 kilometers of usage with Inaya showed a much smaller range of time for the same acceleration. So the vehicle performance test proved that it helps in maintaining the engine power, the smoothness and the fuel economy. At the same time helps in the emission loss by controlling the carbon emissions and keeping the environment clean. So the summary, engine performance for clean fuels, keeping the engines operating as designed. Again, I will repeat that the engines were designed to perform with clean fuels, not with dirty fuels. So if you want to retain the original performance of the engine, the design specifications, this injector cleaner would be required, especially for the 5 years plus cars. And it gives you the flexibility of the fuel market use also. In Dubai you have the 5 ppm sulfur diesel, but that's not everywhere. So most of the countries where the diesel is dirty, for the diesel market use also, this becomes a very handy prop that instead of adding or making the quality of diesel much better, which will cost much more, the Inaya or similar kind of diesel injector cleaners or petrol injector cleaners would make their job easy in keeping up the removing the deposits from the injectors. And I think I just made it 2 minutes late, but I was almost running. Thank you very much. Any questions? I was happy to take.
I think we all agree that was a really fascinating, interesting presentation, and I know very educational, certainly for me and I think maybe for many of you as well. And certainly this man is on top of the subject. So let's see if we can test him a little bit. Do you have any questions? Any questions? Even from his friends?
Oh, my God. Who invited him?
It was a good presentation, very exhaustive. I just want to ask one question on the coolants. Now you said all your coolants are based on carboxylic technology. So earlier you had a basic mineral technology. So because most of the market is still having mineral technology, and if the cars coming to your service stations are having normal technology and filled up with ENOC carboxylic technology, so is it okay for them, or how do you manage this situation?
This was the first question we had, because nobody normally replaces our coolant fully. They top it up, and the compatibility issues were guaranteed.
So which means
you can top it up with our basic one if the basic one comes in.
Because generally mineral technology is not
compatible. But this was the testing done by with the help of Afton, and I took it as a precursor to launching this product. Because I have this 60 countries all supplied from the same plant. So if we have an issue, it will be a bigger issue. Don't ask me the formulations, okay? I don't know, you know, I know it.
We provide formulations to many people, so don't worry. Regarding the diesel additives, you did tell that fuel sulfur do not impact the performance of the diesel additive. So for example, when you go to the countries like
higher diesel sulfur, we are talking of the deposits, whichever is happening in the injectors. what I meant to say is that what you do if you have a dirty diesel, either you purify the diesel, refine it more, and take out the impurities, which in most of the third world countries, or not third world I won't say, countries where the regulations are not high, it's not being done. What I'm saying is this can be used by the fuel marketeer to clean up the diesel injectors, which is the first casualty for improper or impure diesel. So this can be marketed by them as a technology, not as ENOC, but as a technology that use this for improved performance. Otherwise they have to bring in cleaner fuel, cleaner diesel. So performance-wise, if the sulfur goes up or down, if the deposits are there, we'll clean the deposits, whether it's sulfur or non-sulfur. One question you said.
One question per topic. So per topic.
Okay.
Out of this subject, ENOC has come up with low sulfur, 10 ppm fuel sulfur. Is ENOC having plans to introduce this?
5 ppm sulfur.
10 ppm.
We have come up with a 5 ppm.
You have come up with a 5 ppm.
Yeah.
So you already come up with 5 ppm.
Yes.
Okay.
We have come up with ultra low sulfur diesel is already introduced over here in the green stations, and this is not for them, it's mainly because for us, we don't market in UAE, Lubricants does. We look at the international, so it's mainly on the international sales.
When you're reducing the sulfur acts as a lubricating agent. So some of the pumps are diesel lubricants. How do you lubricate? Do you add some additives? And these additives, what are the impacts? How does it impact?
I'm not from the diesel or the fuel retailing side, so I won't be able to say, but this was the first question. Why is sulfur kept? Not only that it's costly to take it out, but also because it acts as a self-lubricating for the fuel pumps. This is what we all knew. But I guess that's why that 5% is kept, otherwise the 5% would have also been taken out. Not 5%, 5 ppm. Sorry. But I'm really not from the fuel side, so I cannot say, but I'm sure that's the case, otherwise they would have removed and made it 1 ppm. But that's also coming, if I believe that in the Euro 7, Euro 8, it will come at that level only. But I really cannot answer because I'm not from the fuel department.
So you mentioned this replacement interval for the trucks and buses is 8,000 hours. You also mentioned 650,000 kilometers because it is written in this rating. Normally, the average speed of the buses, city bus, for example, is only 20 to 25 kilometers.
You can take 20-25, you can take the high speed of 40 also.
So approximately it will be in 2 years. In 2 years, you have to change the...
Take the kilometers, take the years, whichever suits you.
So the presentation was showing 5 years, so that is the reason shown a little bit.
5 years for stationary engines is guaranteed.
Any other questions? Thank you very much, Ranjan. I think we'd all want to show a round of applause for a really great presentation.